Good evening, everyone. I hope I'm audible. A warm welcome to the Techloop session on blockchain held by IEEE VIT along with IEEE CET. I'm Anish Panda, a sophomore at VIT studying CSE, and I love to eat, sleep, code, and repeat.
Hello everyone, I'm Anshul Agarwala from VIT Vellore. We both are from IEEE student chapter and today we will be conducting this session about blockchain. Hope you all are as excited as we are for this session.
Cool. So let's start. Remember Anshul, you were telling me quite a while back that you wanted to get a PS4, right?
Yeah, right. You found one?
Yes. So recently, I also thought that let me also get a gaming console, right? So I was looking upon different dealers and sellers and different e-commerce websites. So there's finally a seller who contacted me on WhatsApp, offering me a PS4. Would you like to have a look at the quote he has been offering?
Uh, Bro, he is offering a good discount like 5,000 rupees off, but who buys from WhatsApp? Like, do you trust a person in WhatsApp?
Yeah, makes sense, right? So, I generally do not go for sellers from WhatsApp, but like, I thought to get it checked from you. So recently, I checked on Amazon as well, right? I was telling you that I was looking for different platforms, and I found it on stock over there as well. So I was thinking that I should go with the Amazon one. What do you think?
Yeah, but there is a 5,000 markup. That's a significant amount. Yeah,
But yeah, 5,000 is significant. But like, so suppose if there's anything wrong which happens with the product or something, I cannot go to the WhatsApp guy and be like, okay, this product is wrong, take it back, right? He'll tell that I never sold you this product, or he'll be like, there's no warranty on this, or something like that. But for Amazon, if I tell them that this is wrong, then they'll obviously be like, okay, we are ready to replace it, or they'll consider the warranty and other redressal mechanisms.
correct. Yeah. So, but this is interesting, right? The one selling you in Amazon is also another random person. Like, the company is not selling you something, they are just connecting the buyers from the sellers, right? What will
Yeah,
you
yeah.
do? Like,
Yeah, makes sense. Like, so see, the both of them are random strangers I do not know, but like, see, on Amazon. I've ordered many stuff from Amazon, right? So I do know, I do have a sense of trust with Amazon that they'll not sell me a damaged product, or they'll not sell me a product which is default, or even by chance if I receive that. I've had instances in which I've contacted the customer care and they've resolved my issue. But on WhatsApp, I'm not pretty sure that what can happen.
what would you guys prefer? Like, use the chat box. I would go with Amazon for sure. Yeah, so we have answers like Amazon is not a stranger, right? So,
Hmm.
exactly, like Anish, do you see this? Uh, the same strangers, like this is somewhat related to Uber, right? You won't go and sit with any other person in his car, but we take Uber all the time. Let's dive a bit deeper, like what's happening here. And yeah, let's remember that this is a session of blockchain. So we also have to establish that how all of this fits in. So let's talk about truth and trust first. Yeah. So to make my point, I will use an example. I took it from my class 6 physics book, so it's that simple. Like, have a look at this photo. What does this remind you of? What's happening here? What is this event? This is a very famous event in human history.
Hey Anshul, isn't this the moon landing, right? Neil Armstrong was first person to go to the moon, right?
Correct. This is the moon landing, but okay, I'm gonna make a controversial statement now. Okay, like, how do you know he went to the moon?
What do you mean by this? Like, can you elaborate?
Uh, yeah, I mean, there is a guy in the chat box. He is mentioning about conspiracy theory. So, yeah, I mean, what if this is a conspiracy? Like, this photo could be photoshopped, right? How do you know this is true?
Yeah, makes sense. Like there are scientific evidences though proving the fact that this photo was taken upon the moon. And more than that, not everyone like can be wrong about this. And everyone also knows the fact that this is not fake, right?
I mean, okay, you just said not everyone can be wrong. Uh, okay, is it like what if I give you an example when everyone was wrong? So yeah,
Yeah,
this bits of paper,
yeah.
we have strong memories with this bits of paper we call money. So before 8th November 2016, all of us together called this paper money. But on 9th, after the demonetization happened, a body called the Reserve Bank of India declared that no, these are again bits of paper, these are not money. And the collective truth that all of us believed in all this while, that this paper have value, it was shattered in a moment. So, yeah, let me rephrase that. RBI used its power to override the collective truth, and yeah, this was no longer the money. So, let me repeat that. So, there is the collective truth, a story, mostly a fiction, and we all believe in that, right? So, things like the paper is money or that Amazon is trustworthy. But then there are institutions, government, even companies. They all are the same thing in a way, methods of organization. And we trust them blindly most of the time. And this collective trust empowers them to override all our truth. The power are disproportionate. I mean, like they are often known to misuse it. uh, like reiterating the examples, they demonetize the notes overnight. They can set up conditions to give you loan based on their belief system, and they have all your data, which they can exploit and like do whatever they want. Yeah.
See, Anshul is not trying to paint the devil over the wall over here, right? So he has been telling that the institutions have their own problems, but even institutions have their own advantages. But the problems over here, seen over here, are not less and are often ignored. Like problems like trust in a centralized institution comes with its own risks, right? We have seen that there can be decisions that are also taken in a monopoly. Sometimes there are unfair rules made, and it also leads to centralization of power many a times. Like there is one nodal authority for something, so you cannot contest. Once the body has decided that it's the final decision, means it's the final. There's nothing else you can change about it. And also, we have seen at times that if a big institution fails, then it leads to a huge crash in the economy, and it has also huge effects in the different external scenarios in the current world. So the fact that trust in institutions have its own share of problems. So do you think that there's anything we can be done about this?
Yeah, we have a simple answer: trust no one, in the comment section. But yeah, imagine how would you commit the transactions if you don't trust anyone? You need trust to for things to happen.
Yep, Anshul is absolutely right. So we need trust, but we also need to know the fact that these problems were ignored historically simply because we did not have a solution. We needed those institutions, as the pros with those institutions outweigh the cons by a huge margin, right? So if we did not have the banks, then how would the money transactions take place? or how would others get to know about various stuffs? So what if I tell you that the fact that that's no longer true, right? That's no longer true, that we cannot have trust without institutions. Finally, us humans have invented a technology which you can enforce trust without institutions. In other words, you get the best of both worlds. You have the power of trust in institutions, the pros of that, and you also have the pros of trust in without institutions combined into one thing. And as we all know, that technology is obviously blockchain. So you can see over here, right? We have separated the word blockchain into two different words, block and a chain, right? So why do you think we have done this over here? You can put it out in the chat box, please.
Yeah, also to clarify, like someone has mentioned, like make your own institution. So it doesn't work like that, right? The purpose of institution derives its power from the trust which it has, and I'm not sure like if people will trust institutions, like any institution that pop up made by anyone. So that's kind of impractical.
Hmm. Always says that it's easier to split and understand term. In a way, he's right, right? So blockchain, as the name suggests, is a chain of blocks linked to each other. So let's look at this. Okay. So it's not this simple as wherein you chain the blocks, but it is somewhat similar if you try to understand it properly. Before we get started further, I'd like to tell that blockchain is an invention as influential as the internet or the electricity. And also, one fact I'd like to ask all of you people: how did you know about blockchain? You can put it out in the chat box, please.
Yeah, like where did you heard about this concept first or any of its implementation? It could be your friend, social media, anything.
Elon Musk, Bitcoin. Okay, so there are many answers in the comments. Okay, fine, it does make sense, right? So most of us have heard about blockchain from Bitcoin or any other cryptocurrencies or social media influencers. And this has been because they have popularized the concept. But it's not just that. Blockchain has been existing for quite some time now, and we'll be looking into further about it. Before that, let's understand a few key concepts of blockchain. So, blockchain is a decentralized, distributed, immutable ledger. Right? These words might sound complicated to understand, but let's break it down. As someone already said in the chat box, that breaking it down always helps it to understand easier. So let's get started with decentralized. What does decentralized mean? No individual or organization is in charge of the transactions, right? So basically, there's not a central authority controlling all of the power. It is decentralized among different people. And what does decentralization means? Decentralization means nobody has full authority or control over the network, but rather the authority is distributed to the users who use it, right? So, see, suppose if I'm a user who uses a particular blockchain network, I have the same amount of power as does anyone else who's present in that network. So there's no one above you, there's no one below you if they're the same users, right? Now let's come to distributed. Distributed, as the name suggests, like we have heard in mathematics quite some time, it's shared or spread out among all the users which it is being used by. So basically, there are people present in a various large span of the various landmass present in the whole world, right? So it's distributed among all the people, all the users who are using that particular network, right? So again, as it is similar to decentralization, so all of the users who are being used in the network have control over that. Let's come to immutable now. Immutable, as the name suggests, is the data being stored in a blockchain cannot be changed, right? So one cannot mutate the data. Or basically, suppose I store some amount of data in the blockchain. I store, for example, Anish pays Anshul XYZ rupees, right? So I cannot go and change the data once it's been stored. Once stored, it is completely permanent. And last but not the least, ledger. Ledger is a book or collection of accounts in which account transactions are recorded. Right. Now, there's these much heavy terms that we have looked into, right? Decentralized, distributed, ledger, and immutable. But why do you think that we should care about it? Right. There must be some reason. And before that, if you have any doubts, please do ask us in the comment section. We'll try and help you out with that as well.
Yeah, and if you don't get these terms, like if you don't have clarity regarding these terms, it's okay because we have an interactive demo further in the session wherein we will explore all of this again in more details. So, yeah.
Okay, someone has bit of a doubt about ledger. So basically, ledger is a book or collection of accounts in which the account transactions are recorded. It is similar to like having a record of whatever has taken place. Right? You might have seen security guards enter in who has come in, who has gone out, right? So ledger is the collection of the accounts. It's something similar to that, but not exactly the same. It's just a record of the transactions. Cool. So if anyone else does not have any other doubts, let's move further. So let's start with the uses of blockchain. So as we all know, we have seen earlier, cryptocurrency is a wide used application of blockchain. Right. Blockchain is the basis of Bitcoin and other cryptocurrencies, as we have seen. You might think that the money is money, be it a digital currency like Bitcoin or a physical money like cash. But then when you send money through cryptocurrencies, which are based upon blockchain, you don't depend on any bank, which avoids a lot of hurdles. There's no paperwork you ought to do. There's no others like there's no going to banks and then standing in queues and getting your accounts open. You just have to get your Bitcoin wallet, and then you're good to go. Okay, any crypto wallet works, right?
Yeah, so there is this thing called medical records. It could mean different things to different people, right? So it could be as simple and cute, in fact, as the heartbeat data which your Apple Watch or any other Fitbit collects all the time. So that's non sensitive health data. And it could be your medical prescription, the diagnosis of the ailment, or anything. And yeah, just tell me one thing. Do you think all this data is sensitive? In other words, like, would you like for this data to go public? Will you share your medical diagnosis in Instagram? Say, like, will you upload a story like that? I mean, what makes all this medical data so sensitive? Things like, again, heartbeat data, medical diagnosis, prescription.
I wouldn't personally. I wouldn't go out telling that my heart rate is so and so or my sugar levels are so and so. Like I feel that that is something that should stay to yourself, your family, and your doctor at the most, and not your doctor with a 24/7 access. Only when you go to consult, because I feel that there's someone who can use that against you.
Exactly, it's a kind of weapon, right? We have that in the chat box also. So, someone blackmail material, exactly. So, medical records are considered to be highly secure and sensitive data. And what you want to do is you want to store it very securely. So, like you can say, right, like digitize the medical records, like just store it in any other database like we have now. Every hospital is not every, but many hospitals are already digital. So what's the problem? The problem is again single point of failure. So if the hospital's database goes down, if it's hacked, or if there is a power outrage, you lose the access to your data. And apart from that, the government or even the hospital management have control over that data of your medical records, and you don't know what they are doing with your data behind your back. So how blockchain solves it? If you store all your medical records in a blockchain network, first of all, it will be secure. It can't be tampered. No one can change it. Like if you got to take this medicine, no one can like rewrite that data. So that's another thing. And yeah, you will have the control over your data. You can share it with the doctor if you want with your consent, or you can revoke the consent whenever you want. So that's how blockchain is applicable in the medical sector. Then we have another important application, voting. So oftentimes we hear cases of election tampering, but if you conduct your election process, the democratic process using a blockchain network, everything will be transparent. Transparency, that's another keyword we learned about while learning blockchain. So anyone in the network, anyone who is participating, can see the whole network. There is no secrecy involved here. So when you take the voting mechanism to the blockchain, no one can accuse that the election results are fraud or someone has tampered with the results. And you can have fair elections even in politically unstable places.
Now, I'd like to ask you guys a quick question. How many of you have been to a government office?
Reminds me of cobwebs and a lot of files. I don't want to
Ah,
go there, bro.
terrible times those are, right? You might have seen loads of documents or physical files being present. Like, so there are tons of files present in a dusty environment, and finding your data or your file is a tedious task, right? So like you go, you stand in a queue, that person goes and searches that where is your document. It's terrible. It's a terrible feeling in doing that. So what do you think that the government can do?
I mean, at the least, they can go digital, like they can install computers and store all that data in the computer.
But like even if the government does go digital, you're relying upon your trust of the government servers at the end of the day, right? You're relying upon the fact that you hope that the government servers do not get hacked. But storing these land records on a specific blockchain network will ensure that you have the control and everyone else has the control instead of the one government having the control, right? And it could also cut down on costly title research, and then the insurance, and then the background research being done for insurance and other complications involved with the land transaction or any property transaction. Also, the fact that in politically unstable places, it could also help prove ownership and avoid legal hurdles, right? So you know that many a times you have seen people fighting about the fact that who does the land belong to. But in a blockchain network, since the network is tamper proof, no one can change the transaction data, and no one can change that who does the title or who does that land belong to. So this is how blockchain can help in the government sectors as well, or in helping with different transactions.
Another application is in banking and finance. Like you must have read in the news, big companies like Morgan Stanley and other Citibank, the top financial institution whose main task is to distribute loans to nation states and other big corporates. So they are heavily investing in blockchain because, again, decentralization. These are high risk industries, and like if something goes wrong, there could be a heavy price the company has to pay for it. So they are researching about blockchain. Yeah. So And that's it with the applications. But if you noticed something interesting here, we told you about the applications of the blockchain before we even explained it. Like, we will just start explaining the blockchain now, but we thought it's better to tell you like how applicable this thing is in our real life and in the industry, and that you can for sure make a career out of it, like if you are good at it. So now let's get into the technicals. And so I'm going to walk you through the entire concept of blockchain, and I will do this in a very visual way. Okay. So before I start explaining what a blockchain is, I want you to look at this number. It looks very random. So it's like a digital fingerprint of the data. What do I mean by fingerprint? So, for a general fingerprint, what is a fingerprint? Fingerprint is something we associate with identification. So, just like a normal fingerprint is used to identify a human, a digital fingerprint is used to identify this piece of data. Which piece of data? The data mentioned above here. We have a field called data, and you can write anything here. So, you can write here, maybe let's try my name, Anshul. So, yeah, you see, right? The fingerprint has changed completely. It was a very random number and it's a random number again. But let's observe this now. So, what is this now? The first digits of the fingerprint right now is 4B, 4D, 7. Okay. What happens if I remove the L from my name? Let's try that. Oh, it has changed completely. It's no longer 4B, 4D, L. Hmm. What if I put the L again? Again, the same number. So, yeah, as a matter of fact, every time I type in another character, the hash of the data or the fingerprint changed drastically. But when I enter back the same data, I get back the same fingerprint, the consistent fingerprint for that data. So, yeah, that's what I want you to understand from hashing or fingerprinting. So, writing Anshul there is not very interesting, right? What could we add there? Say, I remember Anish, you borrowed rupees 1,000 last week. Let's write that here. Let's cement that. Okay. So now, having written that, I have the hash, and okay, I will note this down, and I know, like, if you go tomorrow and say like you didn't or you change the value, the hash will change completely. And yeah, so you can't do that, right? As long as I have the hash. So that's what an hash is. And now I want to extend this idea of an hash to something we are gonna call a block. Okay. So what a block is exactly like an hash, just that the data section has been broken down into three sections now. The first one is the block number, which is just some sort of a number. The second one is yet another number called nonce, and we will get into the details about that soon. And the third one is some more data. Again, it could be anything. And you have the hash as usual. So, but notice this. There's something unusual about this hash. It starts with 0000, right? So, why do I say that this is unusual? Because, as I mentioned, right, the hash changes for every entry in the data, and the probability of any hash to start with 40 is really less. So, if you go and like change the data, like if you write something in the data, let's do that, the hash will change. Yeah, we have a different hash now, and it's not something that starts with 0000, right? And there is something else that changed here. a visual change. Do you notice that? Yeah, so the thing is, initially, when the hash was starting with four zeros, the color of the block was green. And when we added more data here, and the hash no longer starts with 40, it's red. So what's happening here? See, uh, think of the hash as a signature, the digital signature, and let's define a arbitrary condition. So say this block will be valid if it starts with four zeros. Yeah, so yeah, this might be a bit complicated, but okay, let me give you an analogy. So think of a bank checkbook, right? So you write some transaction data there, like pay this guy 1 lakh rupees, and you sign the checkbook, the check, for that to be valid. If the check is not signed, it is not valid. So the hash is just like the signature for this block. In the data section of this block, you can write your transaction details like Bob pays Alice rupees 500, Anshul pays Anish rupees 1000, anything of that sort. And you have a hash for that, a signature for that. And that signature has to be valid. Only then the block makes sense, right? So, yeah, that's what a signature is, and it's not valid right now. So you can't change the transaction data, but you have a thing called nonce, and that's a nonce comes in. So look at it. If what if I write one in nonce? Let's check that. So say I wrote this transaction data. Bob pays Laura rupees 100 and Bob pays Alice rupees 500. So this is the data that we have, the transaction that happened. Now if I change the nonce to one, the hash is okay. It's not 0000. Let's change it to 2. uh, Hard luck. 3. I mean, you get the point. Like, there should be a number for which it's completely random, but there should be some number for which the hash will come out to be 0000. 5, 6, 7. What do you guys think? Like, use the chat box. uh, Guess a number which you think will give the hash as 0000.
Hmm. Yeah, there's someone who
15.
says that it can be anything. Well, it is something, right? It is something that takes you to a 0000, but you do not know that number, right? So let's try 15. Okay. Okay, so with 15 we get 1 0, but we do not get all four zeros, right? We do not get starting four zeros. So it is some number that we'll keep trying and trying. So what would you do ideally for this purpose?
Yeah, I mean, I can sit here and type all day, but let's use computers, right? I'm sure you must be wondering what that mine button is. So let's click it and see what happens. Oh, the block is green. And look, we found a number. Oh, it's 0000. And what's the nonce? Uh, okay, that's a big number. So, yeah, brute force. So, what we do is instead of going through all the numbers one by one, we write a programming function. Like, think of it as a loop. Like, we check for each number. We check for one, two, three, four, and go on till whenever we find the right number. The right number, if if we put it in the nonce field, will give an hash with first four digit as zero, and once the four digits are zero, this hash is signed. So let me rephrase that. What is a block? A block has three fields: block number, nonce, and data. The data contain the transaction data just as a regular checkbook, and the check or the block has to be signed for for it to be considered valid. And how do you sign it? There are two ways. You could sit here and check for all the values of nonce till you find a valid number to make it signed, or you could click on the mine button and do a process which we call mining. So you can mine the block and it will become valid. So yeah, and I'm pretty sure like now you understand what a blockchain is. Let's go to blockchain. So from the name, like it's probably just a chain of blocks put together. Let's try that. So I have this block, block number one. It has some nonce to it. There's some data. We have pre-populated it for you. And yeah, but there is another field called previous. Okay. We have another block. In fact, we have five blocks if you scroll. So block number one, block number two, block number three, four, five. And each have some data, block number, nonce, previous. Okay, if you take a closer look at the previous field, so the previous of the fifth block is same as the hash of the fourth block. Yeah, if you could zoom it and show. Those are same, and the previous of the fourth block is same as the previous of the third block. Okay, yeah, so that's what previous is. It's just like copy the hash of the preceding block to the previous field of the next block, right? So, and yeah, like now it's obvious that the previous of the first block is a set of zeros because we don't have any block preceding the first block. Okay, having said that, let's explore the fifth block again. So we have some data here, but what if someone tries to tamper with it? Maybe someone paid someone some amount. What if someone goes and change that? Yeah, maybe change the amount. Guess what will happen? What just happened here? Okay, it is red now, which means it is no longer valid. It's not signed. So what can you do? I mean, you can mine it again, right? Let's mine it. Let's find a different value of nonce and make it valid again. Okay, it's valid. The value of nonce is different now. Fine. Okay, now the most important and the most interesting part. What happens if someone changes the data of a historical block? What do I mean by historical block? An old block, say the block number 4. So what if I go and change the data in this block? Yeah, any guesses? Yeah, so you can see, right? So when you change the hash of a historical block, the next block is also invalidated. Why so? Because when you change the hash of the previous block, the block number 4, its hash will change obviously when you change the data, and that hash will be copied to the next block in the previous field. And when the previous is changed, the hash which is dependent on the previous is different. It's not 0000 for both the blocks. So what will you do now? You have to mine both of them. So let's do it. So to make it valid, to sign this block, you have to mine this, and then you have to go and mine the fifth block. Yeah. Now a very easy question. What if I change the value of the first block? Yeah. Let's tamper with this data. Something similar will happen, right? Okay, let's try doing this. Oops. Everything is red, exactly. And we have to mine everything again. So, what does that mean? Like, how does that look like? Let's try mining everything again. Okay, I mean, it's fine, right? It can be done. That took 15 seconds. Like, if you are a human, if you didn't use this mine and you put in random numbers, that will take ages. But you have the computers. Everyone have computers, so you could just work it out, right? You can mine it. But the point here is, we just have 5 blocks here. And if you think about any practical blockchain, say Bitcoin, they have millions and millions of blocks. And it's more difficult to mine those. So the time it takes is really high. So you must have heard about the graphic card shortage, which Bitcoin miners have caused. So that's for the similar reason. So they are trying to mass up all the computing resources of the world, so that they can mine it faster. So if they can mine it faster, they can go back in the block and they can like change historical data. In other words, they can hack the blockchain. But one guy also mentioned in the chat box the 51% attack. So what you need is, you need the 50% of the computational power that the world has. There are so many computers all around. Like if you check Google, their combined computational power is just 2% of the entirety. So even an organization as big and powerful as Google can't hack blockchain. So the more blocks you have in the past, the harder it is to change. And so that makes the blockchain resist mutation or tampering. And that's why this is safe. So yeah, we will sum all of this up using a simulation, which will, make it even more clear. Yeah. So here is a record. Say two person are committing a transaction. So we will abstract that out as a box, a record, and okay, let's move forward. And so, what is a block now? A block is just collection of several records. There could be n number of records. So we call the combined thing a block, and the block has a hash, a fingerprint of its own, and a fingerprint of the previous block. So that's well visible in the simulation. And connecting with the previous fingerprint is how they form a chain. So yeah, watch the simulation once again. Yep. So yeah, next slide, please. Yeah. So that is me trying to explain you blockchain, and I hope I hope that made sense. And yeah, so I talked in the abstract terms like the physical blockchain, but now we will go into the specific application, which is cryptocurrency, and that will be more relatable with all the news regarding cryptocurrencies coming in. And Anish will be explaining that now. Over to you, Anish.
Cool, Anshul. That was a nice explanation about the basics of blockchain, and it actually did make it a lot way easier. But okay, as we said earlier, blockchain looks easy, but isn't that easy if you dig deeper. So let's go further about it. Now let's again get back to this question. How did you guys get to know about blockchain? Please, like put it out in the chat box.
For me, it was Elon Musk. Fanboy here.
Pretty much sure it was for many of them present over here. Like many people have seen Elon Musk tweet about different cryptocurrencies, about Bitcoin, and when Tesla buying Bitcoin, and many other influencers as well, right? Okay, so Yeah, so like let's get started about cryptocurrencies. Okay, so one thing I like to make it clear over here, right? All of us know like cryptocurrencies is the way that we have all started, and but Bitcoin isn't the only cryptocurrency like out there in the market. So but like we know that cryptocurrencies are present. Like cryptocurrency is a digital currency, but like it is based upon blockchain, so there can be many different cryptocurrencies present, just like Bitcoin. And then we have our favorite Dogecoin, right? So there's Dogecoin, there's Ethereum, and we all know that. So let's make it clear that Bitcoin isn't the only cryptocurrency in the market. There are others, as I mentioned. Let's look at a few more different cryptocurrencies. So you can see that there's Polka, there are different kind of cryptocurrencies present over here. Oh, let me ask you a quick question over here once again. So now that we have seen quite a few cryptocurrencies, how many of you knew about this from before, or how many of you own any of these?
Come on, you can tell us. It's not illegal yet. No one?
Hmm. I've heard quite a few of them personally. What about you, Anshu?
Yeah, I have, from the images, I have heard about Bitcoin, Dogecoin, Ethereum, Bitcoin Lite. Yeah, that's it.
Hmm. Okay. So like okay, so there are these many, right? So everyone's not generally expected to know of these. So let's look at this short meme we have. Okay, so for a proper trader, for a person who's deeply interested into cryptocurrency, they know about quite a few different coins. But like for a person who doesn't have any idea about cryptocurrencies, that person would know Bitcoin or at the most Ethereum or some coins being popularized by different memes or different influencers. Okay. And now let's come to one common fact. So here you can see that we have mentioned blockchain is not cryptocurrency. But why? Just let us ponder upon this fact. There's a very common misconception that like blockchain is cryptocurrency and Bitcoin is blockchain, or like Bitcoin is cryptocurrency and stuff like this. But I repeat, Bitcoin is not blockchain. But then what is blockchain? Blockchain is a technology while Bitcoin is its implementation. Let us think of it as something similar to the internet being the technology and websites being one of the implementations made possible with the help of the internet. Or for foodies like me who love to relate things with food, instead noodles being the concept and Maggie being its implementation. Many of the times, like we have seen people call different instant noodle brands as Maggie, right? So like, yeah, someone else mentioned in the chat as well that Node is the only backend possible. That is not true, right? So we have seen it in the Mern session held earlier as well. Like there are different backend frameworks that are there, but Node is one of the most popular ones being used in the market. Okay, now that since we have learned about a bit of basics, but between what is the difference between Bitcoin, blockchain, and cryptocurrency, let us look at a few uses of cryptocurrency and how they can help us. Okay, so first I'd like to mention that cryptocurrencies are similar to real life currencies, right? It is extremely secure and involves little to no transaction costs. You can access your money anytime and anywhere you want. Okay, and there since there are no transaction limits involved, you do not have any hurdles of change in the transaction limits or increase in them. And cryptocurrencies are not dependent upon banks. It gives us the freedom for anyone to go and open crypto wallets and different accounts because paperwork isn't involved and there are no hurdles with that. And at last, international transactions are fast, unlike wire transfers. which at time takes ages with a huge complicated process. And there's a lot of work that goes behind tracing and wire transfers, and we might have faced problems as well. Now let's look a little further. The life cycle of a crypto transaction. Okay.
Yeah, before
Before
we get
that,
into the life cycle, do you guys have any question? Like, feel free to ask. Let's clear that out. So the life cycle will be kind of a review of whatever we did till now. So it will be crystal clear then. So anything which you want us to repeat.
or any doubts you have, anything you want us to explain it to you in a different manner, something which you might have not understood.
Yeah, Ayush. So we talked about several implementations of blockchain, like we mentioned healthcare records, finance, NFTs, and things like land records, properties. So think of blockchain as the internet of value. So uh, when you talk about the normal internet, so it's the network of information, right? You could send any information from one computer to the other. So when we talk about blockchain, it's a new internet being built. So think of it as the internet of value. So anything which you can associate value with, Bitcoin. So we say Bitcoin is valuable, right? So we can transfer it from one network to the another. So same as medical records, land records, NFTs, which NFTs are used in artworks, music labels, things like that. Yeah. So will nonce be
Someone
always a number? Yeah, Anish, would you like to take that up?
No, nonce will not be a constant number, right? So nonce is that we use the nonce to find, in this case, as we discussed, the first four digits as zeros, right? But in the real life application, it is not that simple because we have huge amount of data, and to control that, different cryptocurrencies have different arbitrary conditions that the first 16 or stuff like that. And we have seen that with different data the nonce value changes. So we can see with the example as well, examples we have seen. So different data, different transactions have different nonce values to make the hash function, the first four digits of the hash as zero. And coming to someone else asking that are the blocks embedded in databases or act as a separate ledger change. So basically blockchain is a database, and blocks are the records stored in that ledger, particular ledger.
Yeah, so
And
we don't
anyone
store it in a separate database. The blockchain itself is a database. It's a decentralized database, decentralized, distributed, immutable database. You could like loosely use the term database instead of a ledger. So, yeah, that's how it connects. Hope that's clear.
Cool. So if anyone does not have any further doubts, let's get into the transaction life cycle of Bitcoin. Okay, before that, I'd like to walk you through how does a UPI transaction take place. So first, what do? You open your UPI application, scan the QR code of the person who you want to send money to. Right. After that, you fill in the amount that you'd want to send, enter your UPI PIN, and your work is done at your end. Right. Then what does the bank do after the UPI PIN is verified and check in whether that there is sufficient balance existing in your account? The transaction is then processed, and then the money is sent to the receiver, and the receiver receives a notification or message saying that he has received so and so money from so and so number and stuff. And then that is how the transaction takes place in a normal UPI scenario. But now let's talk in detail about how does a crypto transaction take place. So let's get started with what does a crypto wallet look like. A crypto wallet consists of the user details, basically the name, the account ID, and then different cryptocurrencies held by the particular user. It is just like your other digital wallets, just but in this case, it's for cryptocurrencies and not for cash, like not for Indian rupees. Okay. Now, what if you want to send a person a Bitcoin To make this process a lot way simpler and easier for you people to understand, let us take an example. Let us take suppose that Rob wants to send zero point 0.3 BTC to Laura. Okay, so for those of you who do not know, BTC is Bitcoin, similar to INR for Indian rupee. Okay, so now let's look at what is taking place in this visual. Rob opens his Bitcoin wallet. After opening his wallet, he scans the QR code of Laura's address, and then he fills in the amount and then clicks on send. What happens after that? We'll look into it a little later, but let us understand that for the senders, it is as easy as how does the UPI transaction takes place, right? Where the sender scans the QR code and sends the money, and for receivers, it is as easy as that finally as well, where the receiver receives a notification that the money has been received. But then, since we are here, present over here, to learn a bit more about blockchain take and that we have a keen interest in this topic, let's look into what happens behind the scenes of it. Because, see, for senders and receivers, it's just the same thing. But behind the scenes, there's a lot of changes taking place that makes your transaction a lot safer, and you basically get to have tend to trust it more at the end of the day. Hmm. So at first, the wallet signs the transaction using Rob's private key. So let us consider the private key as like a secret code, which is visible only to the user themselves to show it that it was theirs and like nobody else's. This helps in verifying the authenticity of the transaction. For example, let us think about your ATM pin. Okay, so when you go to your ATM and you want to withdraw money, right? So you put in your card and then it asks you for a pin. You enter your pin, and then once it is verified, you get to withdraw your cash. Similarly, the private key is helpful in verifying that you are the authentic user or not. So the private key is only for yourself in this case. Like there's no one else who knows about your private key. The bank doesn't know and stuff. So and then after what happens after this, the transaction is first checked across the network. Then after it is verified properly, the transaction is propagated and validated by the network nodes. So what happens after this? Miners include this transaction in the next block to be mined. Okay. So as Anshul has mentioned earlier, mining is the computational process of calculating a certain hash. So it's the mining time for the miners. And then what happens after this? The miner who solves the proof of work propagates the new block to the network. Okay, so what is proof of work? It might sound a little complicated to understand, but let's break it down. Let's relate it to some real life example we all have seen. You can take it as like, um, at when you were in school, your teacher used to give you homework, right? Saying that do this and then get show it to me tomorrow or something like that. And then the next day when you used to go to your class again, she used to ask that have you done the homework? Okay, everyone used to obviously tell her yes, irrespective of the fact that they had completed it or not. But like, so the teacher didn't trust you, obviously. So what would they do? They would come and ask that, can you show me something that says that that proves that you have done the work, right? So you used to show them your notebook that here I've done my homework. So showing the notebook was like the proof of the homework you have done. Like, so in this case, the proof of work that this transaction has taken place is basically what the miner solves, and then it propagates it across the network. What happens next? The nodes verify the result and propagate the block. After that is done, Laura sees the first confirmation. And since these transaction takes place in block, so if there's different transactions that have taken place in different blocks, new confirmations appear with each new block that is created. Okay, so as mentioned earlier, we saw that it was very easy for the receiver to receive the money, for the sender to send the money. And but behind the scenes, in the middle, where people, where what happens behind our back always, the process is a lot way safer, lot way open for us to know how does it take place, and it is trustworthy, right? At the end of the day, you have something to trust upon without a big institution. We have seen that there are many failures with institutions, with transactions taking place without proper proof, or with transactions taking place and then frauds happening and people running away, right? So we have been trying to fetch proper data. We have been trying to figure out mechanisms that how can we solve these problems so that in the future we'll not face any major issues. So blockchain is like the key to what you know that can solve our major issues, and then that can also solve various different problems we have faced in our day-to-day lives, and various huge amount of taxpayers money being lost. Okay, yeah. So you guys might be thinking that we have learned a lot about blockchain, but we did not cover what few people might be expecting over here is the prices of Bitcoin. But we did learn about blockchain, right? We did learn about how does it transaction life cycle take place, what are the key terms used in blockchain. So let's have a quick look back at what took place. So we did have the four key blockchain terms. Blockchain is a decentralized, distributed, immutable ledger. We saw about trust without institutions. We saw the different applications of blockchain. We saw that what is there in a block, what are records. Then we saw that what is there in a proper block with the hash function. And then we saw that how does a chain takes place, right? And after that we saw about cryptocurrencies, the different cryptocurrencies present, and then how does a transaction life cycle of a crypto transaction takes place, right? And then we saw about crypto wallets. Okay, this might have been a lot to comprehend, might be or might not be, but you might be thinking that why have we been pre- stressing the fact about the emphasis about blockchain. So it has been predicted that blockchain technologies could boost the global economy by around $1.76 trillion by the year 2030 through raising levels of tracking, tracing, and trust. Blockchain has shown immense potential to disrupt major fields and solve main life problems.
Yeah,
And
so
you know,
we have a question. So, what makes a particular cryptocurrency more profitable than others? So, yeah, uh, Arya, the value of a cryptocurrency is all about perception. So, if the people, if all of us as a collective believe that this cryptocurrency is more valuable, then the prices increases. But again, that's up to speculations, and we are not covering that here.
we are not here to speculate upon market prices, right? Market prices are subject to market risks. Please stay tuned with that. So we have heard that many a time. So we do not want to predict upon prices because that is not what is in our control. So but what we know that what does take place, what can take place behind the scenes, and how can blockchain solve major problem. We might have heard that blockchain has been implemented in different vaccine ledgers being implemented, so that we have heard that many vaccine doses were stolen earlier, but nowadays blockchain has been implemented in a trial manner or even in a proper physical scenario, that so that we do not use any vaccine doses. We all know, right? COVID vaccines are like important for every one of us to stay safe and stay at home safely, and so that once we all get vaccinated properly, we can go back to our day-to-day life. It has been a difficult time for the past 2 years, but yeah, so vaccine ledgers have been implemented so that we do not miss out on any important doses. There's no malpractice being followed. There's no wastage of vaccines as well, right? So if anyone has any other doubt, please do post it in the chat box. Okay.
We are almost in the end of the session.
Um. we'd like to thank all of you for attending the session, and we hope that you learned something new and something different to comprehend. Okay, please do fill in the feedback form that is mentioned in the chat box. And also, if you need any resources or if you need the slides to what we have used in the session, please find the links to that in the chat box as well. Anyone has any further queries, we are here to solve them for some time.
Okay, I don't think anyone have any more questions, so we could wrap this up.
Thank you everyone for attending this.
Thank you.